Okay, if you're starting the first worksheet, the first thing you're going to want to do is make sure that your name is at the top, like mine is, and just the way we marked our relations web the other day with tools, we're going to mark this one as a practice. It's not something you can use on a test. It should go into the practice pocket of your folder after you submit it. We're going to start by reading the directions and seeing if we can figure out what we're supposed to do. The directions say, given the domain, find the range values. So what I recognize right away is there are two words here that I know really well. Domain, which are my x values, and range, which are my y values. Knowing that, if I go back and reread, it says given the domain. So they're going to give us a domain. And if I look at number 1, it tells us right here what the domain is. Then I need to find the range. So that's the work that I'm going to have to do. One of the ways I know that's pretty easy to organize domain and range, in fact, the easiest and most organized way we have, is in a table format. We are able to say, if we know some x values, and we have an equation here with an independent variable or a domain value here, and a dependent variable here, we can do some math and we can figure out one if we have the other. Remember from our web the other day, part of what we said is that every single piece of a relation, including the equation right here, has to do with finding points on a coordinate plane or dots that we could make on a coordinate plane. So because I'm dealing in all domain right now, that means that all of these numbers here, 4, 6, and 8, would all go down the left side of my column. I would put x equals 4, x equals 6, and x equals 8. So if I know my x value, I'm going to go back over to my equation. What that means is I know 3 different coordinate pairs. One of them has a 4 where the x is, one of them has a 6 where the x is, and one of them has an 8 where the x is. What my job is then is to figure out when the x is 4, what does that make my y, or my range value, also known as my output. So I'm going to do a little calculation here, and I am going to say that my y value for 4, for the first one, my y value will be equal to my x value of 4 minus 5. So if I can do a little bit of quick PEMDAS math, I know that 4 take away 5. One strategy I have is to treat it kind of like we do our equations and say, well, I've got a positive 4 and a negative 5, and if I add those together and I cancel out 0 pairs, I would have y equals negative 1. When my x value is 4, just like it is over here, that makes my y value negative 1. So I go back over to my table and I say when my x value is 4, my y value is negative 1. The thing is, now I have to repeat it 2 more times, but instead of x being 4, now I have to go back and say, in the case where x is 6, what would that make my y value? Because it's probably not going to be the same thing, especially if this is a function. So now I have to go back to my equation and start over again and say, if y is equal to, I'm going back to my original here, and I'm taking that x, and instead of replacing it with a 4, I'm going to replace it with a 6. Minus 5. Well, 6 minus 5 is pretty easy to do. That makes y equal to positive 1. So I'm going to go over to my table and transfer that information. When my x value or my domain value is 6, my range or my y value is 1. And now you'll just need to go back and do that one more time for 8. That's pretty much the pattern you're going to follow all the way through this sheet. A couple things to remember and point out though. Thing number 1, don't ever forget your PEMDAS. When you get to number 2, for example, you've got 3 times your x value. If you can't remember that, you may want to make yourself a note, right? That 3x is the same as 3 times your x value, right? So when you're replacing, you don't forget to add that, to have that multiplication piece in there. And because there's multiplication and addition, don't forget PEMDAS style that you need to do your multiplication first and then add 1. And that will be true for all of these. You always have to remember PEMDAS when you're doing multiple different calculations, different operations in one problem. Another thing that I want to point out to you is that there are some fraction problems on here, but they're not much different than what we've done before. I'm going to take number 4, for example, and I'm going to take my domain values. I'll do 2, you can do the third. And I'm going to make a table. I'm going to put my x values on the left, and my y values will be on the right once I calculate them. The 3 things they're asking me to calculate are a domain or x as -10, x as 0, and x as 5. So I'm going to go over to my equation. Check this out. First thing I'm going to do is highlight my x and where I'm going to have to replace my x value, and highlight my range, my y, my output. And I realize that what I'm going to have to do here is multiply 3/5 times x. Well, we've already kind of done that in the work that we did around fractions. If you can remember, we talked about this being the same thing as 3/5 of x. Just like when we have something like 2x, that's the same as 2 copies of x. In the old days, it would have looked like 2 triangles. When we have 3/5 of x, that would be like having 3/5 of a shaded triangle. So when I go to my first domain value of -10, I'm going to depend on my picture of what 3/5 is. I'm going to shade, I'm going to shade in 3/5 in yellow. There's 1/5, 2/5, 3/5, okay? And I can keep depending on this same picture over and over again. What this is asking me to do, if I follow the language, this is asking me to take 3/5 of my x value and then add 2. The first thing I have to find is 3/5 of -10. Well, the first thing I need to do is divide -10 equally among my fifths. If I divide -10 equally into 5 different parts, because that's what fifths are, each part would be worth -2, -2, -2, -2, and -2. Each part of my fifths is worth -2. So now if I go back and take a look at what 3/5 is, 3/5 of -10 is just these 3 squares instead of the whole 10. It's -2 plus -2 plus -2, which is -6. So I'm going to kind of go back to my math here and say for my first one, I have y equals 3/5. I'm going to use parentheses for my substitution for multiplication here. -10, 3/5 of -10 plus 2. Well, I over on the right-hand side have calculated that if this is 10, 3/5 of 10 is -6. So that means that this portion right here is really the same as -6. So now I can go through my problem and say -6 plus 2 is equal to -4. Y equals -4. When my x value is -10, my y value equals -4. I'm going to mark that over here. Then I'm going to go to, I'm actually going to leave 0 because that one's pretty easy. 3/5 of 0 is 0. You can have that one for free. I'm going to go back over and try this whole thing again with an x value of 5. So I've got to go through the same procedure, but if I go back to my original, I'm just going to erase these 2's because these 2's are what my fraction looked like when I was talking about a whole of 10. I'm going to go down to the third domain value, the domain value of 5, and say if I am dividing 5 into fifths, that would mean that my whole would have 5 equal parts of 1. And now if I focus my attention on what 3/5 of x is, when x is 5, that would mean 3/5 of 5 would be 1, 2, 3. So I can go to my equation, and I'm actually going to have to do some work on the right here because I'm writing my font is too big. My equation says y is equal to 3/5 of 5 plus 2. And I have calculated that 3/5 of 5 is 3. Now I can just take a step back and say y is equal to 3 plus 2, which is 5. So when my x value is 5, my y value is also 5. So I'm going to go back and record that into my table. Don't forget how easy it is to find 3/5 or 1/2 of a number. Make sure that you remember that as we come back over to the right, I'm going to do a little erasing and try to mark this up for you. This whole block that you're going to create represents x. And then your job is to find that fractional part of x. In my case, I had to find 3/5 of what x was. X was 5, so 1, 2, 3, 4, 5. And 3/5 was my highlighted portion. You can do this. If you want to use your fraction pieces, you can, but this is totally doable. As you move down, you'll notice you have to do some graphing of some of the points and some other things, but this sheet is pretty much all covered by this video. So do your best work and check in with me if you need help.